Hey everybody, and welcome to this video on adding and subtracting polynomials. So, without further ado, let's make it happen. Alright, before we go ahead and start adding and subtracting polynomials, let's start with a couple of questions that will help us understand the concepts behind the scenes. For instance, how much money is in the picture below? Now, I'm sure you thought to yourself, $16.11. You wouldn't say $1 and $10 and $5 and 1 cent and 10 cents. You group together the dollars and you group together the cents and you say $16.11. Or for instance, when I say, what fruits are in the picture below? I'm sure you would say 3 watermelons, 4 apples, and 2 oranges. You wouldn't, for instance, read it from left to right and say a watermelon, an apple, another watermelon, an orange, another apple, another orange, another apple, and a watermelon. You group together all of the same types of fruits. It's quite literally apples and oranges. And the long and short of it is, when you have things that are the same, you group them together. If they're not the same, you can't group them together. Now, it's important for us to figure out what the same means when we're talking about polynomials. And we don't really use the words the same. Instead, we're going to talk about like terms. And what are like terms? Two monomials are said to be like terms if they contain the same variables raised to the same powers. So here are some examples of like terms. For example, 6a plus 3a. A is a variable. It can represent any number, and we don't know what number it represents. But I do know that we have 6 of that number and 3 more of that number for a grand total of 9 of that number, so we can combine these to make 9a. Or 7b squared minus 2b squared. I don't know what number b is. I don't know what number b squared is. But we have 7 of that number minus 2 of that number for a grand total of 5 of that number. So we can combine these terms to make 5b squared. Or 7 plus 15. We've done this plenty of times. These are definitely like terms and we can definitely combine them and we end up with 22. And last but not least, 4m squared n to the third minus 7m squared n to the third. We don't know what m is. We don't know what n is. We don't know what m squared or n to the third power is. But we do know that it's a number. M squared times n to the third is a number. And we start with 4 of those and we subtract 7 of those for a grand total of negative 3 of them. So we can combine these terms to make negative 3m squared n to the third power. Now here are some examples of terms that are not like terms. And why aren't they like terms? It's because we're trying to combine some of one number with some of a totally different number. So you can't combine them. For instance, 2 plus 3a. I don't know what a is, so I don't know what 3a is. There's no way we can combine 2 and 3a. We just leave it as is. Or 5k minus 8k squared. We don't know what number k is. We don't know what number k squared is. But k and k squared are different numbers. So we have 5 of some number minus 8 of a totally different number. We can't combine these at all. We just leave it as is. For the same reason, p squared times h is a different number from p times h squared. So we've got 9 of one number minus 2 of a different number. It's apples and oranges. We can't combine them. We leave it as is. But whenever we have a polynomial that has some terms that are like terms, we want to group these together to make things easier for us. And of course, we want to put our polynomial into standard form. These are 2 ways of simplifying our polynomial and making it easier to work with. So for example, in this first polynomial, I see that we've got some like terms. And what I like to do is I like to actually draw a line or a bridge between our like terms. So for instance, we have a 15m to the third and a negative 6m to the third. And if we were to sum those together, we would get 9m to the third. We've also got a 7m squared and a negative 3m squared. And if we combine those, we get a 4m squared. And so this right here is the simplified version of that original polynomial after collecting like terms. All right, this second one's a doozy. We got a whole lot of stuff going on. And here's the strategy I would suggest. Since we know that we eventually want to put this into standard form, I start by finding my terms of the highest degree. So I'm looking and I see that degree 3 is going to be the highest degree of any of these terms. So I'm going to go ahead and connect all of my terms of degree 3 and then combine them. I see that we've got a negative 3x to the third, and a 5x to the third, and also a 2x to the third. And those are going to combine to a 4x to the third power. Then I move on to my next highest degree, which I think is going to be degree 1. It appears that there are no degree 2 terms. So I see we've got a 5x, and we've also got a negative 3x, and we've also got a 7x. And those are going to sum up to 9x. So we've got a 9x. And then all we should have left are our degree 0 terms. So I see a negative 8, and I see a positive 9. Those add up to 1. And so this right here is the simplified version of that polynomial after collecting like terms. In our third example, we actually don't have any like terms. None of those terms have the same variable raised to the same power. Alas, but we can still put it into standard form, and it's always a good idea to put your polynomial into standard form. And that's going to look like 2m to the 6th minus 4m to the 4th minus m to the 3rd plus m. And so we would even say that this polynomial right here is a simplified version of the original polynomial. And it's the same thing with our last example. It appears that we have only one term with an exponent raised to the 4th power, so that'll be the first term in a polynomial when we write it in standard form. Now let's look for terms that are of degree 3. I see we've got 1 here, and we've got 1 here. 3h to the 3rd plus 2h to the 3rd will give us 5h to the 3rd. Now let's look for degree 2 terms. We've got a 4h squared minus 5h squared, and that's going to add up to negative 1h squared. And then last but not least, it appears that we have just one single h by itself, and we'll tack that on the end. And here is the simplified version of that original polynomial. All right, so let's go ahead and practice adding and subtracting polynomials. So consider the two polynomial addition problems in front of you. Now, what's great about adding polynomials is that these parentheses are completely unnecessary. We can actually rewrite the exact same addition without parentheses. And now it's just a matter of collecting like terms, which I'm confident you now know how to do. So why don't you pause the video, and for each of these mega polynomials, why don't you collect the like terms and simplify the polynomial, making sure to put it in standard form. And when you're done, play the video and we'll see how it went. Alright, now subtracting polynomials is going to be a bit tougher, but I think we're up to the challenge. Before we actually start subtracting polynomials, let's recall some properties of subtraction that we've used before with real numbers. Remember, whenever you're subtracting one number from another number, you can always write this using addition. For example, 5 minus 9 can be written as 5 plus negative 9. Of course, we know that's going to end up being negative 4. When do we normally use this? When we have things like 7 minus negative 15. We can rewrite this as 7 plus positive 15. We end up with 22. We change the operation from subtraction to addition, and we change the sign of the number that we were subtracting. Same thing goes when we're dealing with monomials. For instance, 2x minus negative 5x, we can rewrite as 2x plus positive 5x. We change the operation from subtraction to addition, and we change the sign of the thing or number that was originally being subtracted. And we end up with a total of 7x. Or similarly, negative 4b squared minus negative 7b squared, we can rewrite as negative 4b squared plus positive 7b squared. Change the operation from subtraction to addition, and we change the sign of the thing or number that was being subtracted. And we end up with 3b squared. And it's going to be the exact same idea when we're subtracting big polynomials. Here we have one polynomial minus another polynomial. And we can rewrite this as addition so long as we change the sign of every number in that second polynomial. That is, the negative 3a to the third becomes a positive 3a to the third. Positive 3a squared becomes a negative 3a squared. Negative 4a becomes positive 4a. Positive 3 becomes negative 3. So we change the operation from subtraction to addition, and we change the sign of everything in the polynomial. So we end up with this problem. And now it's just like all the other problems we've taken care of. All we need to do is collect like terms, put it in standard form, and we're good to go. All right, now this last problem sure is a doozy. And one way to make it a little bit easier on ourselves is, before we actually do any of the subtraction, or addition, if it were addition, is to just immediately collect the like terms within each set of parentheses. Now you've got a little bit less to deal with, it'll make life a little easier, and if you did it like I did, now you've got your first polynomial and your second polynomial in standard form, so it should be a little bit easier to collect like terms once you rewrite the subtraction problem as an addition problem. So let's go ahead and first rewrite it as an addition problem. We change the operation from subtraction to addition, and we change the sign of every term in that second polynomial. And now that we're dealing with addition, you can totally disregard those parentheses because we don't need them, and all we have to do is collect like terms, and we're done. Now, there is another strategy you can take when subtracting polynomials, and it involves what I'll call distributing the negative sign to each term in the second polynomial. For instance, in our first subtraction problem, you have this subtraction going on, and what you can do is you can apply that subtraction sign or that negative sign to every term in the second polynomial. And you realize that you end up with a positive 3a to the third, and a negative 3a to the second, and a positive 4a and a negative 3. Or, in our second example, you have this subtraction sign or this negative sign, and you have the option of distributing it or applying it to every term in that second polynomial. And so you end up with a negative 6m to the fourth, and a negative 2m to the third, and a negative 2m to the second, and a positive 4m, and a positive 7. You can totally use whichever method you want. This second method requires you to be a little bit more diligent, and it's a little easier to make a mistake and forget that two negatives make a positive. The other way takes a little bit more time, but it's a little safer, and we're less likely to make a mistake. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.